So welcome back to my channel, guys. So today we're going to learn about giant covalent structures. In giant covalent structures, you've got to learn three things: diamond, graphite, and silicon oxide, which is in day-to-day life known as sand. So let's take this as a pleasure and let's move on. Well, what are giant covalent structures? So giant covalent structures are that they are structures that there's a 3D network of strong covalent bonds throughout the structure. These giant covalent structures are macromolecules. There are three types of giant covalent structures you've got to know. It's diamond, graphite, and silicon oxide, which is known as sand. So now let's learn one by one. And before that, there's an important thing to learn: allotropes. Allotropes are the different structures formed by the same element. Now, guys, this question would be asked in the exam: what are allotropes? And you have to say allotropes are different structures formed by the same element. There are two allotropes of carbon which are also giant covalent structures, and they are diamond and graphite, which we're going to learn next. So now let's learn the diamond. Well, these are the two allotropes. You could see the two pictures of diamond and graphite either side. Okay, so now let's learn about diamond. What's diamond? So in diamond, each carbon atom is bonded to four other carbon atoms. Each carbon atom around it has a shape, has an arrangement, and that arrangement is a tetrahedral arrangement. So if I repeat, in diamond, each carbon atom is bonded to four other carbon atoms, and each carbon atom has a tetrahedral arrangement around it. Okay, so now simply this is diamond. You've got to remember this picture because there's a lot in this picture. I'll come back to this picture later. So properties of diamond: high melting and boiling points. More energy is needed to break the strong covalent bonds between the large number of atoms. Hard. Why is it hard? More energy is needed to break the strong covalent bonds. Simply the same reason goes to both high melting point and boiling point and hard. Now, does not conduct electricity. Why? To conduct electricity, there must be free electrons, but diamond has all electrons used in bonding. All the electrons are used in bonding, so there are no free electrons. Free moving electrons, no delocalized electrons, so it cannot conduct electricity. And insoluble in water, that's something common to all. Now, what are the uses of diamond? Now you know it's hard. Well, so it's in drilling and cutting tools, it could be used. Why? Because diamond is hard. In jewelry, because diamond has a shiny surface when cut. That's why I said to remember that picture. In jewelry, because diamond has a shiny surface when cut. I'll show you that picture. Here you go. So you could see shiny surface, and also it's hard. So you could see that this is surely can be used in jewelry. So that's why. And guys, it's expensive, very expensive. And platinum is the most expensive. Well, no, why is that? Because they are very unreactive. They are the most unreactive uh, elements. Okay, so then now this is the structure of diamond. Okay, this is the structure of diamond. So you could see in this structure that one carbon atom is bonded to four other carbon atoms. Now here in this structure you could see one carbon atom bonded to four other carbon atoms. And as I said earlier, in this part, in the not uses, in the properties part, that not in the properties. Well, I said that it has a tetrahedral arrangement, right? Here you go. That each carbon atom has a tetrahedral arrangement. So that is represented in this picture. Not this. This one. So you could see over here, around each carbon atom, there you could see, over here you could see that around each carbon atom there are 4 carbon atoms bonded. Around each carbon atom there are 4 carbon atoms bonded. See, 1, 2, 3, and 4. Around this carbon atom, 1, 2, 3, 4. Around this carbon atom, 1 carbon atom, 2 carbon atoms, 3 carbon atoms, 4 carbon atoms. So you could see around each carbon atom, 4 carbon atoms are there. And the structure, this structure, this structure is defined as tetrahedral arrangement. This structure is defined as the tetrahedral arrangement. Got it, guys? Okay, let's move on. Graphite. Now we're done with diamond. Now comes to graphite. In graphite, well, it's different from diamond. In graphite, each carbon atom is bonded to 3 carbon atoms. Well, if you in the exam have a question, compare diamond and graphite, you could use this as a main point. Because why? In diamond, each carbon atom was bonded to 4 other carbon atoms. But in graphite, each carbon atom is bonded to 3 other carbon atoms. In carbon, there are 4 electrons. We know that in the outermost shell. We know that in carbon, there are 4 electrons in the outermost shell. That's why it is in group number 4. Because outer shell electrons are equal to the group number. Now, as it forms only 3 bonds, 1 electron is left around each carbon atom, free. 1 free electron. What does that mean? It conducts electricity. Well, that's a special property of graphite. So, you could see that this is a use of diamond, graphite. Because graphite is used in pencil lead. Because mainly, if you have asked that question in the exam, you must write, because graphite is dark in color. That is the main reason for it to be used in pencil lead. Okay. So next is that this is the structure of graphite. So you could see layers of carbon atoms. And in between those layers, you could see some dotted lines. These lines. Well, what are these lines? What are these lines? Well, these lines are the forces, the attraction forces between the layers. Those are the attraction forces between the layers. And those attraction forces, those weak attraction forces are defined as the van der Waals forces. Okay? Got it, guys? Okay. And you know something. These weak forces, due to these weak forces in graphite, these layers of atoms, carbon atoms, slide over each other. Now, another comparison you can do between diamond and graphite is that around in diamond, around each carbon atom there are 4, and also it's a tetrahedral arrangement. But here you could see around each carbon atom there are only 3, and it's not a tetrahedral arrangement. It's a hexagonal arrangement. You could see 1, 2, 3, 4, 5, and 6. That is a tetrahedral arrangement. Sorry, that is a hexagonal arrangement. That is a hexagonal arrangement. Okay? That's a hexagonal arrangement. Now we could see the properties of graphite. High melting and boiling point. Conduct electricity. Soft and slippery, insoluble in water. High melting and boiling point because it has very strong covalent bonds around large number of atoms. Conduct electricity because it has that 1 free electron which I told you earlier. Soft and slippery because of those weak van der Waals forces that makes the layers of carbon atoms slide over each other. Insoluble in water, I said that it's common to all. Next, uses of graphite. Well, graphite is used as electrodes because it conducts electricity. as a lubricant for locks and engine. Why as a lubricant? Because it's soft and slippery. Why is it soft and slippery? Because of that weak van der Waals forces. Conduct electricity. Why? Because of that free electron. In pencil lead, here guys, you must say that in pencil lead, graphite is mixed with clay, and the reason to be used in pencil lead is that the color of graphite is dark. Got it? Okay. Then comes silica or sand or silicon oxide. So we are over with graphite. So silica or sand or silicon oxide. You must learn that in silicon oxide, each silicon atom combines with 4 oxygen atoms, and each oxygen atom combines to 2 silicon atoms. Now this arrangement, guys, it's very important. You must know how the atoms are bonded. In diamond, it was that 1 carbon atom to 4 carbon atoms bonded. In graphite, which is 1 carbon atom to 3 carbon atoms bonded. And in silicon oxide, it's a bit confusing. It's that around each silicon atom, it combines with another 4 oxygen atoms, and around each oxygen atom, it combines with another 2 silicon atoms. Okay. The structure and properties of silicon oxide are similar to that of diamond. Okay, are similar to that of diamond. Okay, the structure and properties of what? The structure and properties are similar to that of diamond. So it means that silicon oxide has a tetrahedral arrangement. Well, properties of sand, high melting and boiling point. You know that. Because why? The same reason. There are a large number of covalent bonds between large number of atoms, so more energy is needed to break them. Does not conduct electricity because there are no free electrons. I said earlier, similar to that of diamond, all the structural and also properties. Hard. Why hard? Because of the same reason as high melting point and boiling point. You see like that, okay? See, I said the same thing for diamond. So you could remember that if you remember diamond properties, that's the properties of sand too, or silicon oxide. Then comes the uses of silicon oxide. Well, silicon oxide used as an abrasive. What's an abrasive? Something that is used to scratch things out. Sandpaper. Used to make furnace lining. Why? Now abrasive used as an abrasive or sandpaper because it's hard. Used to make furnace lining because of its high melting point. Now, a furnace is where there's a higher boiling point and a melting point, where's a higher heat energy, so it could melt. So it's used to make furnace lining. It's used to make furnace lining, okay, because of the high melting point and boiling point. Now, uses used to make glass because can see through. Now, when you say about that furnace lining thing, don't mention boiling point. If you won't mention, that's good. But the most important thing is melting point. Okay, there's a higher melting point. Okay, all right. So now that's the end of our lesson, guys. Okay, so hope you got everything done in a broad manner with pictures and a good understanding. So if you want more videos regarding chemistry and other biology or some physics videos, or if you want a particular lesson or some questions to be clarified, you could put the questions in the comment box. Okay, and also the videos you require in the comment box. And for more videos, you could subscribe me, and also you can click on the bell and click all, and then you could subscribe for more videos and like my videos and share my videos. And thanks for watching, guys, and have a nice day.